Hi, I'm Aaron Stash with the Electric Home Show. Today we're touring a home that is not quite finished, but is destined to be net zero energy here in Oak Park, Illinois. We're going to see the 1 foot thick walls, we're going to look at their ground source heat pump, and we're going to talk to the architect about what inspired him to create this house. So stick around for the Electric Home Show. I'm Aaron Stash. Welcome to the Electric Home Show. We're here today again in Oak Park, Illinois at a net zero energy construction site. This home is almost ready and we're going to take a look inside and talk to the architect and learn more about it. Hi, I'm Aaron Stash with the Electric Home Show. I'm here with Denny, the architect on this project in Oak Park. And tell us more about this beautiful house.
Well, this house was built for a homeowner that is a grandparent. And so the idea, the concept was to take the living spaces and make them completely accessible on the first floor. So we have living, dining, laundry, and the primary bedroom suite on the first floor. But they do have guests, they have grandkids.
Right.
And so upstairs is the kids zone. We have 2 bedrooms, a study, and kind of a playroom / loft.
So it's really like starting with that age and place.
Yes.
Where you've got low thresholds and everything
exactly,
like that, no tripping hazards.
Correct. This homeowner came to us with kind of 3 metrics. Is 1, we want to age in place. This is the last home we will live in. Number 2, we want it to be incredibly comfortable and energy efficient. And then number 3, we want to basically use zero energy. So 2 and 3 are very tied together. And that's sort of how we came to a zero energy ready home.
And before we get into that, I just want to make sure that everybody knows this is still under construction.
Correct.
This is not the complete product.
Yes.
We've got some ways to go to put finishes on there. They're like, wow, what's going on? There's no lights in the backyard. So we're getting there. We're mid-construction.
Exactly. Yeah, we are, I'll call it 80% of the way through construction. The keys are supposed to be handed over to the homeowner mid-December.
Okay. So. Thanks for watching the Electric Home Show. If you're a homeowner interested in a healthy, energy-efficient electric home, reach out to us at electrichomecompany.com to schedule your free virtual coffee today. Thanks for watching. So Denny, tell us about the net zero energy. How do you accomplish that in this house?
Yeah, so in this house, we have a couple things going for us. We have an incredibly robust wall assembly, I'll call it.
You said like foot thick walls?
Yes, we have foot thick walls. It's double stud construction. So we have a 2x6 exterior stud. That's doing our water control. It's doing our air barrier.
Okay.
And then we have an interior stud wall that is also insulated. So 12 inches of cellulose insulation blown in. Then inset on that, all the windows you see here are triple glazed windows.
Right. Yeah, these are some hardcore windows
they're
out there.
European tilt-turn style windows. So they turn up. You can open it like a door. You turn it all the way up and it tilts down at
really
you.
Cool.
Sort of like a safety issue to still get some ventilation. But between the air barrier and the super insulated walls, we were able to reduce the amount of
it's like your heating and cooling load is really
our heating and cooling load went from maybe a house like this size might be a 5-ton system. We need 2 tons to heat and cool.
Oh wow!
This
and
house.
how many square feet are we talking?
It's 2,900 square feet.
So 2,900 square feet. Yeah, typically 4 or 5 tons.
Exactly.
Now you're at 2 tons.
Exactly. So the thick walls allow us to reduce and therefore conserve. And then we went back and forth between doing air source heat pumps. That's how we originally were bid. But the homeowners were really interested in ground source heat pumps.
Yeah, so tell us more about that. We saw the system in the basement. We're in the backyard where I'm assuming we
are standing on the well field right now.
Okay.
So we have 9 wells that go anywhere from 50 to 70 feet underground.
Not much to look at right now.
No, unfortunately.
Right? Everything's underground.
Unfortunately, it's about 5 feet underground. But so instead of an air source heat pump where we're doing a heat exchange via air, we're using the ground as basically our energy battery, right? So we're stealing energy out in winter, we're dumping energy back in summertime, and that goes into the inside unit through, essentially a heat exchanger, and then that's heating and cooling our house. So it works very much like a typical furnace. It looks like a normal furnace. There's nothing fancy about it. but it is about 4 times more efficient than your typical gas-fired or even electric-resistant furnace or heating system.
Right, right.
So that then brings down our loads so much that we can offset that load then with solar, which is on the roof.
Okay, so how many, so we can't get to the roof right now, but how many solar panels are up there? How big of a system?
So we have 26 410 watt, I believe is where we landed, solar panels up there. And so that's slated to do 107% of the load.
Okay.
So, you know, also helping us here is the load is being based off a family of 4. There's only 2 people that are living here, so we will probably be much lower than what's anticipated. Just because there's not the number of occupants and plug loads and lights.
And then we saw some batteries in the basement as well.
Yes.
I'm assuming obviously that's tied into the solar.
Correct.
Like why was that chosen?
So we chose the batteries for a couple reasons. One, since we're all electric, we don't have a backup generator or whatever. If the power should go out, we want to be able to run a sump pump, keep our food from spoiling, you know, kind of everyday concerns that we all have.
I think a lot of people think about solar panels like, oh, well, if the power goes out and I've got solar panels, I can just have power.
Correct.
But that's not really how it works.
Correct. Yeah, you're right. Usually, I mean, all this solar that we're creating is given right back to the grid, right? So when you have a battery, it allows it to go to the battery first and then to the grid.
Right.
And so you actually have the ability to use the solar on your house. And so we have 2 Tesla Powerwalls downstairs. And those will allow us to basically run a house with, if the power were to be out for 7 days, we could heat and cool the house.
All right, so if the power goes out in Oak Park, we know where we should come because you guys are going to have all the power here.
Bring your food over, you know, whatever you need.
So speaking of food, the kitchen's still under construction.
Yes.
But talk to us about the other electrical elements.
Yeah. So, you know, since we're all electric, we're induction cooktop. Our firm and all of our projects, we try to push people to induction. You know, we like it from the instant hot water boil to then, you know, the reduction of gas in your house, because that's, you know, one of the number one leaky appliances. You know, you would never go into your house, drive a car into your house and say, let it run, but we do that every day with a gas
or
stove.
Just have your campfire inside,
exactly.
right? Yeah.
So, you know, once we create that analogy for homeowners, it's a very easy switch. It's like, well, yes, why would I not do this? And, you know, it's a low-hanging fruit, we find, and kind of a gateway into then some of these other technologies like air source heat pumps, you know, heat pump hot water heaters, etc.
Right. Yeah, we saw the heat pump water heater downstairs connected to the storage tank, connected to the ground source heat pump. It you know, it just proves that the whole house is a system, right?
Correct.
It's all working together.
We're stealing BTUs from here to move it over there. You know, that's kind of the name of the game.
And so I think the only thing maybe we didn't touch on was like laundry systems.
Yeah.
Right?
So the laundry, similar to the water heater, it's a heat pump based dryer. And so we're using the LG wash tower.
Okay.
It is actually right behind the door there. That's the little mudroom area that has the stackable washer dryer. And yeah, it's a really nice little system. We could have done electric resistance, but you know, it's electric resistance is 1 unit of energy in gives 1 unit of energy out. With our heat pump, we're 2 to 2.5 times more.
And then
efficient.
you don't have to duct that system either, right?
Exactly.
Okay.
So
getting through that foot thick wall, that's a bigger duct.
We you know, in order to keep our energy loads down, as many holes as you can remove from the building, the better, because that's just energy wafting outside.
Well, and that's a good transition to my next question. So we've got this foot thick wall, super tight house. What about fresh air? Like, are we going to suffocate inside there?
That is a great question, and so many clients ask us that. It's like, well, I love having windows open. You know, you're telling me I have to live in a hermetically sealed box, and that couldn't be further from the case.
Well, I was told that I was born on the wrong planet because I'm allergic to everything.
Oh,
so
sure.
I would love to have windows open, but the outside doesn't like me.
And so we definitely have had clients like you as well. So what's really interesting in a high performance home like this is we have an energy recovery ventilator, or an ERV. We say that that's sort of the lungs of the house. So we are taking in fresh air from outside.
Right.
It runs through a heat exchanger, and it's serviced then to living spaces and bedrooms in the house. And then we take stale air from the bathrooms, the mudroom, because it has a laundry machine in this case, and also the kitchen. And then that pre-warms or pre-cools the outside air and refreshes it, you know, every couple hours.
Right, so you've got that fresh air coming in all the time.
Yeah, so, you know, if it's a beautiful day out right now, but say it was 100% humidity and we had a wildfire, and we can't open windows, we would, you know, be filtering it at the ERV and still bringing in fresh air. Now,
this is a beautiful house. It's new construction.
Yeah.
Do you focus mainly on new construction, or do you do retrofits as well?
We do both. Yeah. There's a big push in our firm, and also we find kind of nationwide about dealing with retrofits, because 90% of the building stock, 95% of the building stock needs to be retrofitted.
It's already here, right?
And there's a lot of embodied carbon there that we don't want to just throw away. So new construction is in some cases easier to go all electric, right? There's less items to change or swap over. But a lot of our projects lately are renovations that are doing a deep energy retrofit or an all electric renovation to get them off gas.
And is there any rule of thumb or places that you start with on a retrofit situation?
Yeah.
Like, are you putting a foot thick wall on an old house, or like,
no,
what do we got to do there?
We have.
Okay.
But that's the exception.
We got to see that one next episode.
Yeah. That's the exception to the rule, I'd say. So we have sort of a deep energy retrofit matrix, if you will. So to us, if you have an existing home, you don't want to rip off all your drywall, plaster, you know, you want to live there.
Right.
One of the best things that you can do is try to air seal your house.
Okay.
So having the ability to air seal gives you an air barrier. It keeps just the air you're heating and cooling from escaping outside.
Right. It's kind of like putting a coat on, right? It's getting a little chilly outside.
Exactly. And if you can get the air barrier in there, then you can start looking at things like replacing the windows, insulating. And if you can do those three, you've now brought your heating and cooling system down into the land of heat pumps.
Right.
And so that becomes an easy, you know, say you have your furnace is 5 years away from hitting its end of its useful life. If you do those steps first, now you can get a right size system that'll be a little cheaper, more efficient to operate. So you can start to do these small changes as you need to.
Right, because again, it's all working together as a system.
Exactly. And you know, the big part of it all too is just eventually, my house, a lot of houses in Oak Park, you know, we only have 100 amp service. So that then becomes another, in a retrofit, a little bit of a hurdle, because oftentimes you'll have to bump up to at least 200 amps to kind of run all these new electric systems, right? But in the end, we think, and most people think that in these homes that it's well worth it.
Oh, absolutely. Well, yeah. I mean, healthy air, safer indoor environment,
more comfortable,
more sustainable, more comfortable for everybody. No, this was great. Thank you again for showing us around.
Yeah,
appreciate the time.
Yeah, thank you very much.
Thanks again to Denny Burke from Tom Bassett Dilly Architects, as well as the Oak Park Climate Action Network, Boise Construction, and the Illinois Green Alliance for presenting this family-style electric home tour. I'm Aaron Stash. Thanks for watching the Electric Home Show. Like and subscribe for more. If you're an industry professional interested in joining our network, reach out to us at electrichomecompany.com. Thanks for watching.